Okay, we are live. We're live, and what I'm going to be doing in this particular session is checking the validity of some of the models that I've been constructing, or some of the synthetic models that I've been constructing for my synthetic data. So this is going to be hopefully we're going to see this is all working. Yeah, it seems to be working fine. Okay, so what I've been doing, if you're curious as what I'm doing, have a look at the link on the bottom right. But currently, I am writing up this manuscript, which is and here's the tentative title for this manuscript, which is looking at how we can create synthetic data sets to approximate sensitive data sets, so we can actually share our data. The introduction is coming along nicely. Been doing a lot of reading and getting this stuff together, but the most important part of this paper is actually the demonstration with data. So here's what we're doing. The first one is an example on oxytocin and self-reported spirituality, and the data is looking good here. And what I'm going to be doing now is the write-up of example 2, which is looking at oxytocin and observed gratefulness. So let's jump into RStudio. Let's load up our libraries. Most important is the synthpop library, and what we're going to do is go down to this particular data set. Lots of messy script here. I'm going to have to clean this up for sure. But to give an example of what I've been doing previously, I have compared to a particular model here, which is looking at how we can actually so for this particular example, this is looking at the coefficient for the regression of whether there is actually a difference in self-reported spirituality between people who were given oxytocin and placebo. The light blue line was the observed. This is the real data. This is what was found in reality, and this synthetic data is the model or the coefficient from the synthetic data. Now, what is most important here is these two things are almost the same. If we look at the statistics, we can see that there is a confidence interval overlap, but basically an exact overlap. And the p-value for the test that these coefficients are different is 0.998, which is pretty close to 1. And the actual test for the overall model lack of fit is a very high p-value as well. But what's most important is the synthetic data set. Let's bring this up. The synthetic data set is no one exists. No one is real. There is no way you can actually identify who these people are because these are not real people. Let's bring this up, see if we can find it. Lots of stuff going on here. It's comparisons. Compare. That is not working. Let's try that. Okay, so to give an example, this is comparing, this is to give a visualization of the synthetic and the original data set. And what it's going to do is it's going to show us eventually, here we go, it's going to show us the distributions. So this is, zoom in a bit here so people can see it. Okay, so this is the light blue is the observed and the dark blue is the synthetic, and these are the frequencies, or these are the counts, and we can see these are extremely similar between the real and the observed. So basically what's happened is by running synthpop, we have created these new data sets which actually have the same statistical properties. When it comes to age, the frequencies or the counts are fairly similar between the synthetic and the observed. There was a measure of religious affiliation, and these things look really similar, very close. And this is here a outcome measure of self-reported spirituality. Even the missing data is actually quite similar as well. But that's all good. These things share all the same properties, but most importantly, none of these people are real. What we can do here is we can see whether any of the units actually replicate real units. Look at the data here. Yeah. So false, 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 false. So of the 79 individuals, so to speak, in the synthetic data set, for all the actual outcome measures, none of those actually mirror the real outcome measures. So there's no way of possibly linking these people together because they don't exist. So not only do we have, so if we go back to our analysis here, so if this was our main outcome measure, the difference here, the synthetic and the observed are basically the same, except, so we're showing exactly the same thing, or almost exactly the same thing, except the synthetic people aren't real. So we can actually share this data with almost zero disclosure risk and still get the same benefits of sharing our data. This is really, really cool stuff. And you get similar sort of stuff. This is looking at an ANCOVA, which is the main outcome. Let's print that. Look at the comparison there. So this is the comparison for the ANCOVA. Two main coefficients here for the ANCOVA. The first one is the oxytocin condition, and the second one is the religious measure of religious affiliation. The original outcome demonstrated, or the original outcome reported, that once you control for religious affiliation, there is actually an effect of oxytocin on self-reported spirituality, which is the outcome measure here. So the light blue line doesn't cross zero, so it was significant. However, although the synthetic, now we actually go back and we can see these things are extremely similar between the synthetic and the observed coefficients. This one isn't significant, but this doesn't necessarily matter because that's not what we're interested in. We're interested in the similarities between these two things here. Let's have a look. Okay, we're looking at the similarities there. So we can see here, overall, the overall model, the lack of fit measure had a p-value of 0.82. So we can be confident that looking at the overall model, which includes these two coefficients here, that the overall model was extremely similar between the synthetic and the original data sets. And when we look at the individual coefficients for the oxytocin condition, which is this one here, that there's the overlap is almost a 90% confidence interval overlap, and the difference in the standardized coefficients is extremely small. There's no significant difference there for both the oxytocin condition and also the religious affiliation. So we can be confident that this is what's termed a specific utility, in that for this specific model, the synthetic data has high utility because it replicates very closely what we actually find with the original data set, which is really, really nice to hear. Just checking out to see what is going on. Yes, okay, that is nice. And of course, you can actually tweak the colors if you want as well there. And there's a few different settings as well for what you can get for those plots there, which is very nice. But to give an example, I've already written up the results here. So we can see that, yeah, there was for the full model, it wasn't significant. And for the actual coefficient we're interested in, there was extremely high overlap. And I also mentioned that because one model was significant, the other wasn't, this doesn't imply these models are different from each other. And there's a really good paper from Gelman that really highlights this idea, which is very, very nice. Okay, we've done that. So let's write up example number 2. Let's see if we can find it in my messy script. Keep going, keep going. Keep going. Yeah, that's the one. All right, let's import it. I had to create this variable for some reason. Don't remember why, but we're creating, we're taking 8 variables from this data set, or 8 variables of interest, and putting it aside. Now, this is the function. This is all you need to do to actually run your, this is all you need to do to create a synthetic data set. Easy, easy peasy. Done. Bam. Now let's compare synthetic against the original. It's doing its thing. working away. By default, with the compare function, it actually has a percentage for on the y-axis rather than counts. But I think counts are a little bit more intuitive. Let's have a look at the data. All right, those things look pretty good. As you can see, some of these things are binary. For instance, drug condition is either 1 or 0, but regardless, these things still look very similar. So by having these similar frequencies here, or by seeing similar frequencies here, this is suggestive of what is called general utility. General utility. Let's close that. Okay. Okay, let's have a look at this. So for this particular okay, so we're looking at this particular analysis, which has 3 different covariates: drug condition, emotional condition, and this is as to whether, and then also the interaction between these 2 things here. What we are particularly interested in is this outcome, which was one of the main outcomes reported on the paper, that there was an interaction between drug and emotional condition, and this was so for this particular example, we can actually see that although the overall model, it's looking like the overall model seemed to be compatible between the 2, barely. The actual coefficient for the main interaction effect, there seems to be a difference, and that's pretty clear with the visualization here. So that's a good example of when a particular effect doesn't work. But let's have a look at this one here. So that one's looking a little bit better. So that was on what you would consider the border of statistical significance in the original paper, and those trends seem similar there. So this is going to be a good example, and we are going to write this up. Going to be a bit boring and copy and paste the format that I used above, which is fine because we're using the same sort of approach. I'll remind myself to complete this intro. That's kind of boring, you don't want to see that. Alright, so let's walk through and see what we found. So the lack of fit, so this is looking at how the model with the 3 coefficients performed, and in the intercept, how these things performed overall. So the lack of fit test is 1.76. So this is suggestive of general utility, well, specific utility for this model. 0.78. 4 degrees of freedom. Here, okay, is that correct? For the treatment. Uh, 0.22, 0.69, or 69, 68.6%. What was that? 68. One day I'll get good at R Markdown and I can automate this. Today is not that day. 68.6%. There we go. Between the synthetic and the observed data. Maybe this will be better in a table. I'll write it up for now. The drug condition. Effect coefficients. 0.38. Another thing is I'm using the Latin Modern Roman font, which is the closest thing you're going to get to kind of a LaTeX-y type font in Word. So it gives you that LaTeX feel without actually fiddling around with LaTeX, and it's a free download, so I highly recommend that. This one was not significant either. Point emotional. Form. Well, not statistically significant. With this and this overlap. Respectively. $77.5. And 70%. Predicting success of a bit. I'll give you a test. Not statistically significant. It's a bit, I'll have to improve the writing a bit to make it a bit more interesting, but this is good. This is good for now. Go back to addressing the general utility before we move on, which is this one here. Inspection, side by side of the variables interest. Suggested sufficient general utility of the synthetic and suggested sufficient. Had sufficient general utility. So the first one that we ran was on gratefulness, I believe. Gratefulness, yep. Okay, so the other thing I want to do is write up and compare the effects, of course. Because what I want to do is verify that everything needs to be structured within a linear model in order to actually do the comparisons between the synthetic and the original data sets. And in order to do that, sometimes it already is a linear model, but then occasionally we have to restructure things. But the good thing is almost any parametric test is just one way. It's just a fancy way of doing a linear model. So it's possible. It's always possible to reconvert these things. So this is exactly what we've done here. This is the original outcome. Come on. Yep. So this is the original outcome reported from the paper, looking at observer-related happiness and the impact of oxytocin there. So we can see here that the interaction effect was 0.06, which is what was reported in the original paper. And the good thing was for this paper, the investigators actually shared the code, so it was very easy to replicate it. And this is the exact code that they did. which is awesome. But in order to use synthpop, we need to put this into the structure of a linear model, which is what I've done here. So this is model 1, which does not contain the interaction effect, which is just the main effect model. And then here's model 2, which is exactly the same, just another way of doing this down over here. And we can have a look at the summary, and the p-value is exactly the same. When you actually compare those two models, you get exactly the same p-value, because it is just another way of doing exactly the same analysis. So then what we've done here is we rerun that, just to remind myself, and run the linear model equivalent, and run that exactly the same analysis on the linear model here, and this is what we get. Just compare that. Using provided analysis script. Go back into that. F163 statistic 3.73, p-value of 0.058. Same p-value, summary M2, 0.058, which was associated with a t-statistic of 1.93. There it is. Estimating it this way. I'm not sure what that's similar. Certainly a lot weaker, 0.049. Sorry, 0.069. See, this is hard to describe because it's not exactly the same. But it's not really equivalent. It's definitely not equivalent. Smaller. Non-significant p-value. There we go. Like a fit test. Therefore, despite really good, right? Despite the fact, I don't know. Despite the fact that this it's hard to say what sort of recommendation you would do here. One would not have yeah, okay, so in this case we wouldn't have, you would still share it, but you wouldn't have considerable confidence in the specific utility of this model. Let's do exactly the same thing for the other one. All right, here we go. Here we go. That was for happiness. Now let's go and do great self-reported gratefulness. Oh, I don't know about that conclusion. That's probably a better conclusion for, to have a look at that again. Chuck this down here for now. Gratefulness. Seven point 0.1 7 4DF 0.4. So copy and pasting is easy, but it's a recipe for typos. It is an absolute recipe for typos if you forget to change a particular outcome measure. I'm being a bit naughty. supposed to be verified. Happy. Gratefulness. That was significant. Just. F163, 4.32. P-value 0.0418. That's close. Close. Round it down, 2 decimal places. Structuring it there. Grateful M1, M2. Get that summary. Exactly the same. Or to T statistic of 2.1. Yep. How are we traveling? 36 minutes, go for another 10 more minutes, like a typical Pomodoro. Nothing like motivating you to work without any focus, knowing that people can be watching you. And I know there's a few watching right now, so that's pretty cool. I'd still be doing it if no one was watching. It's an interesting little experiment. Okay, T statistic of 2.1. Estimates model using synthetic dataset, which is this one here. Let's take a quick look. It's minus. So this does not perform well. Not perform well at all. Okay. Minus 0.33. And 0.74. Like a fit test. Now we're comparing the two. That's what we did before. Do that. 0.02. 39% overlap. Drug condition 0.35. Emotional condition 0.48. 76.2. And 49.6. This model did not demonstrate strong, high, strong, specific utility. Okay, cool. That is another section, another draft section of the manuscript done. and it is approaching 40 minutes, so I'm going to sign off for this live stream session. Make sure you check out the rest of the live streams up on my YouTube channel. See you later.